One of the first things that you need to distinguish in thermochemistry is the difference between the system and the surroundings. And here are two different cases. One is an endothermic reaction and the other is an exothermic reaction. So in the case of the first one, the system is the water inside the beaker. And the surroundings would be the glass, the hot plate, and conceivably the air if we had the whole thing enclosed. So we have heat that's going from the surroundings into the system. In the second case, we have the water once it's heated up, and then as it cools down, the heat goes from the system, which is the water, into the surroundings, which is indicated here. Okay, so another way really to say that whole thing is that the universe, okay, which would, in this case just means everything that we're interested in is the system plus the surroundings. And while this seems really simple now, it's going to be important to us later. So it's important for you at this point just to have those two ideas straight. And this slide just adds a couple of words to describe the situation that we just looked at. So if you have heat that's going into the system, like what we have here, then that's an endothermic reaction. In other words, the heat of the system, which is represented by Q system, is increasing. On the other hand, if we have heat that's going from the system into the surroundings, then that's considered to be an exothermic reaction. So there's two different words to describe the situations. The primary equation that we use to calculate the amount of heat that's involved when there's heat transfer is here. And this just means that Q, which stands for heat, is equal to the mass of whatever it is that's gaining or losing the heat, times C, which is called specific heat or specific heat capacity, times the change in temperature, delta T. And one thing that's worth noting is that delta T is always defined this way, so it's always T final minus T initial. And that will make a big difference in terms of the signs, whether you have a plus or minus, which in it will also determine whether or not you have an exothermic or an endothermic reaction. Let's work through an example just to see how all of these ideas play out. So first of all, over on the side here, we have the water, and then we have the calorimeter. This would be two coffee cups put together. And then we have a way here to measure the temperature. So the first thing that I think is a little confusing is in the previous example we were looking at water, and water was the system. In this case, the system is the reaction that we have here. So the system is calcium chloride dissolving in water. And the water is here is the surroundings. And then you may say, well, what about this? So outside of the calorimeter, we're not concerned with. And the calorimeter itself, we're not concerned with. So the system is the reaction, and the surroundings would be the water. Okay, so we have our basic equation, which says that Q, and in this case I'm going to do Q water, so we're going to figure out what happens to the heat in terms of water. The mass of the water is 50 grams, and the temperature change of the water is, well, actually let me do this first. The specific heat of the water is 4.184 joules per gram degree Celsius. So that's the specific heat of water. And then the change in temperature, so the temperature starts at 25 and it goes up to 28.51. So 28.51 minus 25 degrees C. degrees C. Okay, so QH2O is going to be equal to, so we just multiply. So it's 50 times 4.184 times the difference, which is 3.51, and we get Q is equal to 734 joules. Now, the heat that is gained by the water is lost by the reaction. So we can say that Q reaction is equal to minus QH2O. So Q reaction is going to be minus 734 joules. Okay, so take a look at that, think about that for a minute, and then let's look at the second part of the problem. So in the second part of the problem, we know that we want a temperature change of 9 degrees, and we know the amount of water. So we can figure out how much calcium chloride we're going to have to add in order to make that change. There are a few different ways that we could go about solving this, but let's just pick a simple method. So we observed that when we put 1 gram of calcium chloride into our 50 grams of water, we got a temperature change of 3.51. So we could say, how many grams would it take to give us a change of 9 degrees? So that's just going to be 9 divided by 3.51. So about 2.56 grams of CaCl2. Here's another problem that uses the same basic relationship. So we've got Q is equal to mass times delta T times the specific heat. So we are told that the titanium is going to absorb 4.78 joules, and the mass of the titanium is 5.88 grams. And we'll just solve for delta T, so we don't know that yet, delta T. And we also know that the specific heat of titanium is 0.523 joules over grams degrees Celsius. Alright, so we just do this and solve for delta T. Then when we make the calculation, we get a temperature change of 1.55. And that's going to be an increase, right, because the titanium is absorbing heat. This problem uses most of the ideas that we've talked about so far. So the first part wants us to write the equation for what happens. So remember, when you're dissolving a salt, an ionic substance in water, you don't show water. So that's the first part. Is the reaction exothermic or endothermic? So if it says heat is evolved, then that means that it's exothermic. What is QH2O? So remember that Q reaction is equal to minus Q water. So that means that QH2O is going to equal 1.51 kilojoules. Okay. And then what's going to happen if we put 2 grams in there? What are we going to get for the final temperature? So maybe the easiest way to do this is we're going to take our 1.51 kilojoules and we'll make it 1,510 joules. And then that's going to be equal to the mass of the water. We can use that. And we'll solve for delta T. and then the specific heat of water, 1.84 joules grams degrees Celsius. Okay, so when we do that, we're going to get 24.1, change of 24.1 degrees C. And if we start at 25 and we go up we start at 25, we go up 24.1 degrees, then we'll end up at 49.1 degrees Celsius. So that would be our final temperature. And we know the temperature goes up because the water is absorbing the heat from the reaction.